Data Voyagers.
Hello, Data Voyagers. This is the seventh episode of the Data Voyagers podcast, navigating the story behind the numbers. I am Igor Alcantara. Oi, pessoal. And here with me, Angelika, Klidas.
From the Netherlands. Hoi allemaal, goedenavond.
All right, so we have a great episode for you today. But before we start the episode, just a quick reminders. Please subscribe to our podcast wherever you listen to your podcast. This is very important because it helps our statistics. It helps the podcast to reach more people. So if you either prefer Spotify, Apple Podcasts, Overcast, or whatever platform, just find the Data Voyagers podcast and click follow or subscribe. And while you're there, also give us 5 stars. This all help us to reach more people.
Yep.
And also recommend our podcast to other people, like your colleagues, friends, family, right?
Yeah. I did it. I believe we have some 5-star rankings already, but it's great. Just
we
inform
do.
your friends.
For a new podcast on Spotify, last time I checked, we have like over 30, which is good.
Reasonably.
Yeah,
Okay.
but we want more. We want more.
Yeah, exactly.
And one more thing before we start the episode, just one more announcement. We do have now a store that will help us to support this initiative. All of the money, if any, we collect from the store, use for the initiatives we have. So if you go to our website, datavoyagers.net, you see the link for the store. We have, if you watch the video, you cannot see it here, but I have this. I analyzed the 4 a.m. t-shirt, so all original. So we have a lot of t-shirts, stickers, we have water bottles, we have backpacks, we have a lot of things in our store. So you can take a look at there, datavoyagers.net.
One of my biggest worries nowadays is that I walk into organizations or talk with organizations and they say, we do AI, and then it's using ChatGPT or Copilot. And that was my biggest worry.
Yes.
So that's why we decided, right?
Exactly. So as you said, there's our 7th episode, and every episode, actually, we never planned for this. It happened naturally. We pick like a theme that is related to like pop culture, a movie, a book, or something. And then the title of this episode is Prompt Me If You Can. So that reminds that the Leo DiCaprio movie, Catch Me If You Can. So we're exploring with that team the world of Gen AI. And we had an episode, our 3rd episode, we talk about AI in general, but now we are focusing on Gen AI. So there's a lot of buzz around it. So we're gonna explain some of these. There's a little bit of theory, but don't worry, we walk you through the concept. It's part of our data literacy initiative. So we get our listeners to understand this in a little bit more depth. So what we have here, like for today, is what generative AI is. How these modules actually work, what happens behind the scenes. Some interesting use cases, or maybe some alarming use cases as well. How that influence or impacts like data literacy and analytics and all of that. And we're back with the data storage segment. So on the data storage segment of this episode, I'll talk to you about a paper that discusses how to handle unbalanced data sets. Pretty cool. So buckle up. This is not just another AI primer. It is something that everybody's talking about it. So let's get started. And I'll start by asking Angelika. Let's start from the beginning. What is Gen AI, and why the hype is now, before?
Oh, the hype. The hype, I think, started on November 30th, 2022. Also, the moment that my book, Data Literacy in Practice, was launched, with the launch of ChatGPT, OpenAI's ChatGPT. And from there, everything started rolling, and everything became AI, AI, AI. Even the tech vendors all around the world, they were only talking about AI, AI, generative AI, generative AI, AI, AI. And then, um, but to actually understand what generative AI is and what the difference is when you talk about a topic like AI, because generative AI is a solution made of AI, right? Um, so generative AI is simply models that use existing data from all around the internet, in petabytes, and it creates new content, new images, new text, new words, new code, and everything. And there are various models. I think the world of large language models and RAG models are exploding, and especially in 2025, as I was reading an article about it. But the definition is actually creating new content, right? Um, so maybe you can help me out here a little bit, Igor, because you are more historically historically correct. So if we look at the history of large language model or language models, it started somewhere in the 2014s with GANs, right? GAN, which stands for Generative Adversarial Network.
That is
Um,
correct. Yes.
and yeah, and you have a very great example about it. Um, it's the art, right? It's the dual of the art when you have
Mhm.
the generator and the discriminator. And can you help me to explain that story to the public?
Sure. So the generative addressor network is something that actually my podcast in Portuguese. I remember when they like released the paper, we actually mentioned it. We had like a whole episode about it because it was something revolutionary. And what basically is like AI. We need to validate whatever AI is predicting. So let's say the classic example before Gen AI. Classic example is we giving like a neural network an image of either a dog or a cat, and we want the algorithm, the network, to label it, to tell us this is a dog or is a cat. They have a lot of elements in common, but they have elements that distinguish themselves. So someone at some point needs to validate if the AI is making the correct prediction or not. So the idea behind the GAN, the adversarial network, is that the network itself will kind of do part of this process. So when I say adversarial, it's like it's as you said, it's a dual. So basically, there are two networks working. So when I say network, is a network of artificial neurons, and I'm happy to explain a little bit more later in the episode. What's in a very like few words, what is the because that's what I studied in my master's actually. What is a neural network? But anyway, imagine like a series of artificial neurons connected, multiple layers. That's what we call a network. But we have two adversarial. So basically, there is one that is trying to make a prediction. For example, is trying to identify if an image is either a cat or a dog. So that's what we call the generate. That guy is in this case is to generate. So an image will generate something. Let's say it would generate an image of a cat. So that network it only generates. But then there's the other one, the discriminator, that will try to understand if the first network did a good job or a bad job. Well, basically, we'll evaluate. And then the network, we use that to kind of train itself or to improve itself. It's the math behind it, by the way, it's very beautiful. I mean, I'm those kind of people who thinks math is beautiful. I mean, I have like equations tattooing my arm and all of
Really?
that. Oh yes. And so and what this actually does at the end of the day is like because the discriminator tries to identify what image it looks real, what image is kind of a fake, then it's a network, is a type of algorithm that can generate very realistic images. I mean, if we look back what was possible in 2014. So I remember I used these networks. It was part of one of the trainings I was giving in neural network. We're doing everything in R, and we got like a lot of paintings from Van Gogh, like your fellow
Or
Dutch,
Dutch. Yeah.
and we'll give a series of paintings of Van Gogh to this network, and then network learn how to paint like Van Gogh, and then we give another picture, let's say a photo of myself, and then the algorithm will then do it as in the Van Gogh style. Or artificial neural network was part of the training, and it was like amazing. It was perfect. No, you could tell it was. I mean, you could identify the style. It was very close, but you could see it was an AI. But
So,
this
but
is in
if I
2014.
understand it correctly, to come back to the more basical area, or the basical understanding for me as a non-techie, non-data scientist, we have adversarial networks, the GANs. We have two systems, two neural networks that compete with each other. The one is creating images, and the other one is always saying you're not right. And then at the end, it's that good. It has learned that good that there is no difference anymore. Is that the correct understanding of the GANs?
Yes, yes. I mean, there's other examples, but that's pretty much summarizes what it does. That's why we call adversarial.
Okay.
And that's what I mean. That was the best we had back then. I mean, it's not
Yeah,
even
in
great that we have
2014,
now.
right?
2014, yeah.
And I remember that we had projects going in the firm where I used to work from 2016, 2017. We started working on projects in recognizing and labels from soda cans and soda bottles, and we used Google TensorFlow for that. So we had to take thousands of pictures through all kinds of light and shading, outside, inside, and we had to learn the system. And it's actually, I think about, it's the same system, right? It's with GANs. It learned with TensorFlow in this case, to understand what was right and what was not right. Yeah. Okay. And then in 2017, we had the transformers going. I know transformers are tokens, and they look at the sense and divide it into tokens. Every word is a token, and from there you get some kind of algorithmic um, calculations about probabilities of a word in the sentence. Um, um, and um, and that's, I believe, also the basis for OpenAI's ChatGPT and nowadays Copilot, Llama, and all those other models, right?
Yeah, so that was the. I think in the future we might, and I might be exaggerating. Probably am, because we don't have the historical distance to analyze this. I mean, we're pretty close to the actual event. 2017 was like just a few years ago. But anyway,
Yeah.
based on information I have right now, what I believe is in the future, we'll look at these paper. It's called "Attention is All You Need." It's a paper was published in 2017. And by the way, on our website, datavoyager.net, you'll find an article that I wrote explaining this paper. And also have a video, which is linked on the same article that I also explain in text format and video format, this paper. So
Yeah.
this paper is what created or brought a few concepts that we use today. And I think we'll look in the future for these to be as important to AI as the Principia Mathematica from Newton to be important to physics. I think is that huge of a breakthrough. The authors of the papers, I believe, we're looking at like future Nobel Prizes winners. Like I mean, that's what I believe based on what we have right now in terms of information. It's revolutionary. And as you said, natural language processing and to create text before that was based on probability. So we give like a corpus of text, like we give like thousands and of text, and we have computer creating text based on the probability. So we created, let's say, the cat chased the dog and and what is the most likely word after, and so complete the sentences. And at some point, we'll decide, okay, this is enough of a sentence, and then we'll do a point and go to the next sentence, etc. And we'll create that based on whatever is the next probable word based on the last 2-3 words, which was very advanced.
Yeah.
But this is different. I mean, there's a lot of differences. I'm not going into detail because we do have the article if people want to read it.
Yeah.
But this has one big difference. It brought the concept of attention. So what this means is not only the most probable word, the next probable word, but it's based on the function of the importance of each word in the sentence. So if I say, let me get a more complex sentence. Let's say the cat was eating the food because it was hungry. When I say it, what is it? The food was hungry or the cat was hungry? So because the cat was, it was early on the sentence. So it is closer in terms of distance in the sentence to food than to cat. So old models will think it refers to the food, but we know it refers to the cat because the food cannot get hungry, the cat can. This model, because of the training, it understands that. Well, it refers to cat, not to food. Just like is a very simple way to explain it. I will explain more details later. And that was revolutionary because then we can generate text, not only text, but text specifically with way more accuracy, closer and closer to human language.
And closer to reasoning, as we see nowadays with the GPT 4.0, 4.0, I think from ChatGPT, which is using reasoning just like we humans do. So it's becoming pretty good at the moment. Okay, and I know there are some other techniques involved as well. We have BERT, we have Llama, we have all kinds of things. I love the fact that we have GPTs that are relevant to certain industry for biochemists and so on. So I was reading about it today. As you know, I was studying today a little bit. So that's cool to see. Um, the third thing that I would like to discuss, and maybe even later on another one model. So, as I understood, diffusion models, 2021 plus and now on, and it's becoming better and better. And that is the way we can create images and videos from scratch and from noise, right? I remember that earlier last week, I did a training in Rotterdam, one of our biggest cities here in the Netherlands, and one of the exercises was create an avatar based on a real picture from you if you don't have any privacy issues. So we dropped it in chat. We asked for an avatar, and I really got a nice one. And the second step was that I had this beautiful avatar, and then I've put it into a model to generate a video with some text. And I had even my head was moving, my mouth was moving, my eyes were moving. It was really great to see that with diffusion models that we can do things like that at this time, this era. So yeah, I think that's cool. But can you explain to me in simple words, please, how this diffusion model works, Igor?
Yeah, so diffusion models.
Can you
Yeah,
help me with
absolutely.
that?
So diffusion models. So it's more for, like, as you said, images and video. So let's think images, because video is basically it's a sequence of images. Like it's like cinema. It's a sequence of photographs that you play like really fast. Anyway, so let's talk about image. Generating images. A lot of times, like before this, what happens? A lot of algorithms, they were based on features. I want an AI to generate a photo of a cat. So cat has features like eyes, nose, and all those features. And then and we know the features they have a certain relationship with other features, like the eyes goes side by side, they go above the nose, they have some characteristic. So the neural network learned that, and they were able to reproduce those images. But there were a lot of times things missing, or things there were like added. We call it noise. And I'm not talking like people with six fingers and stuff like. Sometimes like smaller details. So then we get like very recent modules. So we're talking about like the papers published and the first experiments in 2021, but 2022, 2023 is when we get like the most of the use of diffusion modules, and they're getting better and better now. Like if you go to Sora, for example, or the Google algorithm, it's almost perfect. So what happens? It's
Yeah.
imagine you have like static, like from your TV, for example. Not anymore, but old TVs they have the static on the TV. So basically, the diffusion model start with like a canvas, just like that, and basically the module learns two things: how to add noise to a real image, step by step. So to the point that the image becomes impossible to recognize, like how much I can add noise to an image of a cat, and I no longer can identify the cat as a cat. And also learns the second thing, which is reverse the process to then make it the image more realistic. So we start with pure noise, and then we're removing that noise little by little at a time.
Pixel by
Yeah,
pixel, right?
not exactly pixel, because it's like a multi-dimensional matrix. It's way more
Mm,
complex because you have like you layer in colors, like yeah.
yeah.
But it does that, and then at the end you have an image that is very realistic in a lot of cases, depending on how good the module is. So, in a nutshell, that's what it is. DALL-E 2 Midjourney was one of the first to broader use technology to use these
Yeah.
modules, and
Yeah.
they're very good.
There are
Yeah.
tons, right? Yeah. I use Canva a lot, and Canva as well has a lot of AI tricks, tips in it, which is really cool. Um, do you know, by the way, maybe a trick question, but do you know where the name Dale comes from?
It's from Salvador Dali.
It's from
Yeah.
Salvador Dali,
Okay.
yeah, and it's from Wally.
That I do not know.
Disney's Pixar
Yeah.
movie,
Well,
yeah. So I found it out when I was preparing last week for the training. So that was cool.
oh,
I
I love
added
that
it
movie.
in my
Yeah.
training. So yeah, why are those models nowadays so important, Igor? Why? Why now?
Well, because we have there are two things, or three actually. We can break it into three things. One is we have the all the theoretical background that enables us to do it. So we have the theory behind it. We have the math. So all these papers that we describe now, we needed those because it doesn't come like from nothing, from thin air. You need like there is like deep math behind it. Second is these algorithms, they are extremely uh, expensive in terms of how much power they consume. And when I say power, I mean CPU, I mean memory, GPU, and I mean electricity as well. I mean, elect. I think yeah,
Water?
water, electricity. I think there is the amount of water to cool a data center. It's immense. But I think that there might be another episode in the future where we talk about these environmental impacts of AI. But anyway, so that's the second aspect, and the third is these models, they need to learn from something. So the vast of easy accessible data that we have, either code, images, video, text, and everything in many languages. Yeah,
Books,
it's
whatever is available on the internet, right? And we're talking about
exactly. I mean,
petabytes,
there's
right?
all the legal things that the
Yeah.
OpenAI, the companies, they have a lot of lawsuits against them because you're using the data that you're not supposed to, and
Yeah.
you're profiting from like data. but that's a different different conversation. But yeah, you have the data, you have the computing power, and you have the algorithms. So which we didn't have the combination of these three before.
Yeah, yeah. It's interesting, right? It's very interesting to read all about the evolution of everything and it's going so rapidly and it's beyond our imagination what happened in the last 2 3 years regarding the large language models, the RAG models. Today, I read about the click answers bit and how it works. You know, with sending the question, and then it breaks down, and then it comes back again with the mathematical elements behind it, and then you get an answer. It's beyond your imagination what is going on. Um, so, but then the discussion, generative AI or Gen AI is not AI. It's a solution based upon AI
That's a very
algorithms,
good
right?
discussion. So yeah, let's have it.
Yeah, let's talk.
So tell us why Gen AI is not AI. What is the difference?
Well, the difference is, from my point of view, it's a solution that is created with algorithms, with AI. It's a solution, and it's not AI. It's a solution created by
Mhm.
AI. It's just like when I used to scan the soda cans with the app that we built, with the algorithms from Google TensorFlow behind it to see if the label was real or not real. Um, that is also a solution that we have built with algorithms. It's the same with generative AI. The models are
Mhm.
trained with
Yeah, it's a
algorithms.
tool. Exactly.
So that's why I think it's a
Mhm.
solution. And we keep on learning it because what we give back, if we do not have our privacy elements adjusted in the settings, um, we can give back our prompts and the results and the things that we like or dislike back to the system so that it can become smarter, right?
Yeah, which is a benefit and a risk by itself, because
Yes.
who's controlling all of this? So that's another thing. So I believe in that case, as many different initiatives, including academic initiatives, that spread the use of this and the use of data, it's better. So this doesn't become like a monopoly because whoever controls these, it's so much power. Um, so which people believe in, it actually was like the social media still is, but now the this AI, it's a tool, Gen AI. So it's a tool built on top of AI modules, and is very powerful. And
It is. But then, do you agree with me when I say generative AI is a solution based on AI
Mhm.
algorithms? Or do you think it is AI?
No, I mean there's a even a deep discussion like when you think about AI, and we have an episode that we talk all about AI, or a third episode, so I'm not gonna back in details to that. But if you think about what is AI, basically you have some kind of software that will perform a task that was not a specific program to do on that way. Was given an objective, a goal, and then you give an input, and then you provide an output based on the goal. You did not provide every single step, so it's not like a regular programming. So in the, in you know in a lot of cases, you can learn from historical data and if you supervise. So we have all these kind of types. So that's the concept. So like it's the foundation. On top of the foundation, you can build tools that uses that foundation. So Gen AI is one of
Yeah.
those tools that builds on the foundation of AI. So AI is this vast field of different technologies or different techniques or algorithms. We have many for many different reasons, And then on top of that, you have the tools like Generative AI is another example. Generative AI, which I mean probably will be another episode in the future. Generative AI is not AI; it's a tool built on top of this foundation, which is AI.
So it's a tool. It's a tool that helps us to generate new
Yes.
context. And the basis of it all are the
Mhm.
algorithms that we use. And there are millions of algorithms used to learn the
And
models.
usually you
right?
don't use one.
The bigger the model, the more algorithms we have, and the heavier the capacity of the machines is.
Exactly.
Right? So maybe one trick question. We didn't
Mhm.
prepare for this, so I'm going
No
rogue.
problem. Let's do it.
Should we say thank you to ChatGPT if it gives, or Copilot if it gives us a good answer? Should we say thank you?
I would say no for one particular reason. It's just because you basically every interaction you have with any of these AI or any interaction you have with any computer, any machine, there is an electricity cost associated to that. I mean, you're not paying for that directly, but there's an electricity cost. So more electricity is being consumed. Like there's a big problem, for example, that we are having, or will become a big problem with cryptocurrencies. Not AI, but again, mining cryptocurrencies takes a lot of natural resources.
Right. Computing, right?
Yeah.
Computing power.
And so AI is kind of the same thing, but there's a more complex discussion that I think it at least one episode only to discuss that, which is the problem of alignment. What will be the alignment of AI when they when they pass the singularity, when they become conscious? What is the alignment? Because and we used to think, and for our listeners and for you also from Europe, this is in any way. I'm not trying to offend anyone, but it's history. We have a very European mindset because especially in the West. I mean, we have listeners everywhere in the world, but especially in the West, we have this mindset where, because that's what happened in the past, we go to a civilization that we have like a more advanced technology, and what we do, we share ideas. No, we conquer, we destroy, and we slave them. That's what happened historically. So a lot of people have this idea that AI is when it becomes conscious will do the same to us because that's what we did, but not necessarily. It could be that the AI will do the same thing. It could be the AI will see us as a threat, but it could be not. It could be the AI will see us as allies. So there's a problem of alignment, how AI will align to us, because they can simply ignore any command, anything you tell them, and they can have their own agenda. And how we see AI as well, how we will align to AI. We'll see them as enemies. We'll see them as allies. We'll see them.
Yeah, I remember I have read something about Microsoft that launched something like a chatbot or something like a platform like X
Yeah, there was
and
many years
they
ago.
started feeding the system with bad words and bad things, and it started acting bad and biased and rude and so on, and they took it offline.
It put it on and other time was called Twitter. Put on Twitter. It was like over 10 years ago. You put it on Twitter, and then these Microsoft AI was basically we had to learn on Twitter, so it became a neo-Nazi. It became very racist because that's Twitter, and also because a lot of people found out that, and they, as kind of a sick prank, they were feeding like these horrible contents. So of course AI needs, but there was a separate type of problem because it wasn't all a conscious AI. It was just repeating whatever learned without. But it was a very good teaching for us because it taught us that you cannot just go free. You need some kind of guidelines, limits. Like the law, it's one limit. The AI
Yeah.
recommended health guidelines. It's another one that you should feed to these models. Otherwise, you might have uh, like an AI that will recommend someone actually to happen, that will recommend someone to take their own life, or you have an AI that recommend you to do something that is illegal, and things like that. So yeah, it's a constant process to evolve this, to reduce bias, and to make sure it is not causing any harm.
And we have to keep the
Yeah,
human in the loop.
you
We
gotta
have to
keep
keep
the
the human
human
in
in
the
the
loop.
loop.
We have to train them,
Absolutely.
and I truly believe we will come back to the topic data literacy at the end of this
Mhm.
episode. But that's why questioning is one of the most important skills that we have to
Exactly.
work on in the coming years.
How about
Okay,
we go?
enough side
Yeah.
questions. How about telling us, Igor, how it actually works?
Absolutely. So,
But in plain
in plain
English,
English,
in
no
plain
worries,
English,
no
what?
math here. I might drop one on other technical term just as a reference in case later on you want to do your own research. But if you don't get it exactly what one or two terms mean, no worries. Memorize them and throw in a party. You look smart. But anyway, um, and look at data voice because some of these we have articles, some of these we explain in more detail. But basically, how this thing works, we basically have three separate steps. And came mostly from that paper in 2017 for the attention is all you need. So basically, we have three steps: prompt encoding, latent manipulation, and decoding. So very briefly, and then I'll detail a little bit more. Prompt encoding is when your text or image is converted into what we call high dimensional vectors. Basically, you take a text or image and you convert them to something mathematical, which is basically is a multi-dimensional vectors or matrices. Things like a cube with data, and I'll detail a little bit more in a few minutes. Then you have the second step. So basically, that's the input. Let's say you're talking to a ChatGPT. That will be the input. I'll take
A
yeah,
prompt,
I'll
right? The
take whatever you
prompting.
type to a mathematical format that the model will understand. So that's the prompt encoding. So
Yeah.
you encode. Then you have the what we call the latent manipulation. So the model will wander, quote here, through what we call a learned landscape of patterns. That's what we call a latent space. And then it will be guided through what we call layers of attention, feed-forward networks. Again, just some buzzwords you might memorize to look smarter. I'll explain that a little bit in a few minutes. I also explain that in more details with image and with graphs, etc. In the Data Voyages article that I mentioned. So go datavoyages.net, you'll find attention is all you need article there. I explain this in more detail if you want to. And then we have the third. So that was the input. The second is the kind of the processing. And the third is the output, which is the decoding. So we have prompt encoding. So get your prompt, we encode it, process. Third step, decode. So now the vectors, like the multidimensional vectors, that's basically converting real world things to math. Now we have the
Math, yeah.
opposite, like you're getting all of the math output and you convert back to like tokens, for example. Could be words, it could be pixels of an image, could be code, whatever. It's the output that you ask in the prompt.
Yeah, with the as I understood the so every the text is split into mathematical code,
Mhm.
right? And that is stored in a vector
Yes, not
database.
could be, but a lot of times it could be just in memory.
Could be
Yeah. Mhm.
just in memory
Yeah.
as well. Okay, interesting.
Depending on what specific task or module you are doing. So basically, you convert that. When you say
Okay.
vector, it's like you're starting like in mathematical matrix. Remember matrices we learn in like high school. That's basically same idea. So you convert your input to math, process, convert your math to an output. That's it. Now, let's understand
That's it.
first the encoding. So first thing that happens is the tokenization for text specifically. So tokenization is I get a sentence and I split the sentences in small parts. So let's take a sentence. For example, I like this one, a sunset over snowy mountains. Let's say I want to generate an image and I provide as my input a description of the image, but not all the description. I don't describe the details of the mountain no, I just say a sunset over snowy mountains. Now, through multiple process, we'll split this into multiple tokens. So the token will be the atom, the smallest unit of information in a prompt. So depending on the system, depending on the model you're using, if you're using ChatGPT, if you're using the OpenAI GPT, if you're using Llama, if you're using I don't know others, I forgot the name of others, Perplexity, and others, the size of the token is different. But in a lot of cases, the most common scenario is the token will be the minimum unit to represent something. So let's say, for example, the word understanding. So we can split that in 3 tokens: stand, un, end. So the prefix, suffix, and the root of the word. So they will become like 3 tokens. So it's not like a sequence of letters. Oh, 4 letters is this or that. And of course, depends on the language. Like in English will be something, in Portuguese I know will be something else, I know in Dutch will be something else, because the languages are structured differently. Okay, so we have that, and we split in different tokens. So that's the first thing, we tokenized. Now we have what we call positional information, because we not only have to tokenize the order of the words in the sentence. In a lot of languages, they do matter. I know in some languages, like in Czech, for example, because they have like the cases, the declination. If a word is a noun or if it is an object, you change the word, so it doesn't matter the order. But in most languages, it matters the order. So if I say the cat ate, and it's different than ate the cat, same words, I just change the order, the meaning is 100% different. So when I'm doing the process of encoding the prompt, I not only have to tokenize it, but I need to like associate a key, an ID, an index to the tokens, so I remember the original order of the words. Because when I'm working through the next step, the order will not matter. What matter will be the importance, like the relationship, what we call the attention. Right.
So to summarize the first 2 steps is that, first of all, we have a sentence, it is tokenized. So it's split in 2, but a longer word like understanding can be tokenized in 3 tokens. And then in the second step, we also have to remember that the models have to remember the order of the sentence that we have typed.
Exactly. Yes. And then, I mean, for images, then we have like the diffusion that we mentioned, etc. But that'll be, I think, something more complex. I think we can skip that part.
Yeah.
So the result we have from that step, it's what we call a matrix of vectors. So a vector will be like, let's say, a sequence of numbers. Imagine of a vector now is one cell of a matrix. So we're talking like a multi-dimensional, not only 3-dimensional, multi-dimensional. Why is that interesting and why is that important? So, and this is like one of the most important things about this concept, is because the process of encoding gives you what we call is stored in what we call a continuous space. Continuous space simply means that each word or token is represented by the set of numbers, not just one number. It's not like sunset or mountain, snowy or mountain. It's not just one word that represents the meaning. No, it's a vector of numbers, which are basically coordinates instead of one single label. And the coordinates basically identifies how close two words are based on the meaning and based on the function.
That's the
Yeah, based on
probability,
the function.
and that's the probability
So
element.
let me give you an example.
Yeah.
The sentence that I said, a sunset over a snowy mountain, we get, for example, the word sunset. Sunset, because of these properties, the model understands that it's closer to dusk than it is to, I don't know, to noon, for example. And those words are not even in the model, but because it has a previous training, you understand what it actually means, sunset. And when it said closer, you understand also closer in terms not only on description, but understand closer in terms of feeling, in terms of meaning, in terms of colors as well, and shades, etc. And it understands that the color should be based on the sunset, not based on the snowy, because the snowy is closer to mountain than to the sunset. So you understand all of that because it only have one property. That's what is this? Oh, a sunset is this. A snowy is this. Like separate. No, it combines the importance and how close one concept is to another. How? There's many techniques, cosine similarity, Euclidean distance. There's many techniques that we calculate this, but I promise that I will not get too mathy. So
But we have the
yeah,
steps now.
3 steps.
We have the steps complete from top. Yeah. So we have the word, its tokenization. A longer word can
Mhm.
be divided into multiple tokens. Then it also looks at the order of the
Mhm.
tokens, right, which is important, and then it finds, the similarity in the sentence, right?
Or
So like
the distance
kids are
actually.
playing in the park, so playing can be replaced
Mhm.
for breaking a leg or
Yeah,
whatever,
and
right?
that's a problem
Something like that.
coding.
And then we
So
talk
it's
about,
basically understanding
yeah,
what you input in your prompt, what you mean by
yeah,
that. Um,
and that's
yeah.
complex, right? It's complex material. It's complex, and it's so
Mhm.
cool that this technique is here now.
When I say, for
Uh,
example,
why?
I don't know,
Yeah,
Saint Andreas won the match. I understand that I'm not talking about the actual saint or a church or a city. I'm talking about a sports team. So, but I mean, we can go on and on that. Well, let's go to the second of the
yeah,
3 steps. So that's the encoding. Now
yeah.
the processing.
Why do we have to know all this? Why does it matter?
Why does it matter? First is what I said, like because of this concept of continuous space. So instead of storing just a label, we storing the meaning of the label in a vector. We get more semantic precision. So we understand not only what is the grammar function of a word in a sentence, but we understand what is the semantic of that. What is the meaning? Like what is the meaning between the lines? And also the flexibility, because I have what we call continuous space. So you have all of the information, semantics about a word or about a token. So then I understand, for example, that something is might be between an ocean and desert. So for creative thinking, for creative artistic creation and that kind of stuff, or which understanding what something it really is. So we get tags and images. They are more real, more human-like because we're not machines, so we don't write in a precise machine-like way. We write in a more metaphorical sometimes, so it can perform that task because it has the vector of the numerical properties of each word. Now, for the second step in this whole process, remember we have three: the input, the processing, and the output. Let's stop the processing, which we call the latent space exploration. And I'll try to be not to spend too much time in here. But basically, we have many different things here. But what is most important are two concepts: what we call attention and feed forward layers. So self-attention is one of the things that were introduced by that 2017 paper. So basically means that each word has awareness of what it's meaning and what are the influences of other words in the sentence to me, like the cat ate the food because it was hungry. That's the food. Understand what is the function in that, and then also the it and the cat, etc. But it's multi-layer. So then I understand that in multiple levels. So I really understand what is the function of food in regards to that sentence, but I also understand what is the relation between food and hungry. What happens when you have food and you eat, then you're not hungry anymore. So kind of layering up, and you can the model kind of have an understanding of that. And you have the concept of feed-forward networks. So after attention, you have like small, fully connected networks that reshapes this information and will add nonlinear transformations, and then you're able to capture complex pattern. And that's what makes these modules able to produce poetry. You ask explaining what is, and you get like a very like explaining Newtonian mechanics, but in a form of 16th century Portuguese poetry. And it's so complex, most humans would not be able to perform it. And it can because of those multi-layers feed-forward networks and self-attention modules. And this is important because of what they call the context-aware generation. So he understands that how should I color my sunset over snowy mountain image? Well, it's sunset. It gives the color to the landscape, not the snowy. So then what is color represents sunset, and then does all of that in a sense like the shades of red and all, and it does exactly that. So the context aware, and also you can have conversation. You don't need to explain yourself in every single sentence. You explain something, and it gives you an option and say, "Oh, I don't like that. Can you change number 2 in your list?" And he understands what you're saying, and it keeps because he remembers because he have context awareness. Yes.
Yeah, because is that the trick that when you talk to, for example, you ask a question to ChatGPT, a prompt, you do that with the prompt, and then you want to continue based upon that prompt. Is that multi-layered element what you're talking about, that it always can grab back to the subject that we are discussing in that prompt, the initial prompt? Is that what you're trying to explain
it's
here?
the base of that, because then you have the self-awareness. So it centers the whole context.
Cool.
It's aware of the whole context.
Okay.
And I know it was interesting.
And why does it matter to know all this? Why does it matter to know things about the latent space
One is to
exploration?
understand like this, or explain the context awareness generation, and also to understand what we call the control creativity. And understanding this made me a way better prompter when I write my prompt, or they call prompt engineering. I think it's too fancy term to a much simpler thing. Those fake AI gurus out there, they keep like bringing these. Anyway, that's a different conversation. But also because
a different conversation, different topic to discuss. But I know there is a lot of buzz on the internet with self-proclaimed gurus around there. But then they are specialists in generative AI.
Yeah.
How to use the generative AI
So
solutions.
this will make you better at that.
Okay, I think we have a third topic. We have a third
the output.
topic
So
to cover,
we
right?
got the prompt and the ecology.
The output.
The process and the output, which is the opposite of the kind of the opposite of the encoding, is the decoding process. So now we have all of that. Now let's return that back in something that humans can understand: an image, a video, a text, or audio. That's another possibility. So for text, for example, the module gets a list of possible next words, and it picks one based on all the context and everything. And then it adds that and completes the sentence, and it creates a text based on the input based on all of it. And there's a lot of technical terms I just mentioned here in case you want to learn more about it. Like linear progression, projection is one. Softmax is a very, very popular one for neural networks. If we're talking about images, is the diffusion example that I explained before. I like to call it like the Michelangelo method. Michelangelo said, "How you sculpture something so beautiful like today, David?" They said, "Well, I just see like a piece of rock, and I just eliminate everything that is not what I want, what is not, let's say, David." So that's basically the idea. He started with a lot of noise, and it's starting
The art of
to remove the
elimination.
noise. Exactly. It's what I recommend for a
Yeah.
lot of programmers in doing in their code, including Click. Like, you have all of these because you were doing all your process thinking, the discovery. Now remove everything that is unnecessary at the end of the day. And
Yeah, clean up,
yeah,
right? Clean up the art of eliminating the
yeah.
non-relevant things,
And
right?
music, which is one
So
of the singlers,
why again does it
uh,
matter?
uh,
Yeah, why does this
well, it
matter?
matters because it gives us two things. It gives us quality and it gives us diversity. So it doesn't generate all the same text. You can ask the same thing twice, your model will give you different answers because of the probability calculation and all of that. And because it's not only giving you the most likely next token, which will give like the high quality, the lower diversity. But you can, depending on the module, you can adjust that. You want a more creative, less creative response, so you can
Okay.
balance that. And also, it's how we have human-machine collaboration, because you like if you inspect like the decoding parameters, and that is if you're working like on with the API or some of like the inner parameters that these modules have, like temperature to top K, etc. Like OpenAI, when we configure, we need to set those up. How much creative, how much precise you want to be, things like that. You want to study the top 5 most probable words or top 10, etc. So you can adjust that to have a model. So that's why it's important. So that's basically
Okay.
how that works behind the scenes.
Okay, but then we have a big problem still, right? Because as I give trainings around the usage of generative AI solutions, and I always have to explain things about hallucinations. Can you help us understanding in simple English words why hallucinations happen?
Well, hallucination happens because of the purpose of these modules. The purpose of these modules is not to give you factual answers. It's not to give you a answer actually, uh, but it's to give you something. It's to make you happy. Because these models were not designed to factual things only. Is also to creative. You can create fiction, you can create poetry, art, etc. using is art or not art. That's I think there's a term for another. Is AI art? Really art? There's another episode we can do in the future. But anyway, it's not designed for that. So if it doesn't know something, or if the data about certain knowledge is too small, it will fill the gaps with something fiction. Um, so it will, if you ask something about it, it will give you that, and it's designed to make you happy. So if you disagree, even if you're saying, listen, the Earth is flat, it will treat Earth as flat because it wants to make you happy. It will not wants to disagree with you. Um, so it can get like made up fact, like, oh, here's a quote from Einstein about ice cream, which he never did. Or which, but also good if you want to do something creative. You can create like elephant with like with zebra stripes on it and maybe wings. I don't know. You can
You can do
do wherever you
things.
can.
You can
So,
really do.
but if you want factory
Yeah.
stuff, you need something that is designed to give you factory stuff. So there has a layer that only give you something. It has a source to it, like click answers. That's the biggest advantage of click answers. If it
Yeah.
doesn't know something, it doesn't hallucinate. Just say, I don't know.
No, I don't know the
And which is
answer.
what I want to
Yeah.
know when you don't know. I want to know the limits of your knowledge so then I can provide you with the right knowledge. So that's
Yeah.
in a nutshell how it works. Now, how it's been used.
Yeah. I think we covered already 1 hour of
Yeah,
topics,
but
right?
that's okay. I mean, that's okay. It's an important topic. We can talk about it. The how it's been used.
And maybe split it up.
Yeah.
Yeah. Yeah. I think we are moving on to the third segment, and that's about where generative AI is used and maybe even sometimes misused, right? Um, so as we said in the beginning, generative AI, I use it a lot, right? I use it to create text, make blogs, or draft a brainstorm, do a brain dump. Um, but people can use it in various ways, right? It can be from blogs, drafts, poetry, legal templates, news articles, uh, images, visuals, videos. You name it, it's everywhere. But even videos, right? I was playing around, as I explained earlier last week, by creating an avatar based on a picture of myself. And the second step was to create a video, and only with 200 characters spoken word. And it actually looked amazing. I have it, but it's not useful now to do it in the podcast, of course. But if you are curious, I can just put it on the and send it to you, Igor, so you can put it on the website. So but that's creative content, right? We can use it for a lot of creative things, as I do. The second section, I think that we use it, and I think you will use it more, most likely, is developer productivity, using it for code snippets, code generation, maybe even for documentation. Do you? Do you use Gen AI to look at it from for script snippets and so on?
You know what?
Or
Not as much because I got so much hallucination with things I do. A lot of times I find it easy to just do it myself. But however, I do it for summarization because I'm
Mhm.
not good at it. I wrote a few books, fiction books, and the most difficult part was not to write the book, was to write the summary of the book that goes on the cover, the back of the cover. It took like
Mm.
weeks to write like 2 paragraph summary. I'm not good at
Yeah,
all.
I can
I don't
understand.
use to
Yeah,
generate a lot of text because I like writing. So I don't want AI to do one thing that I
yeah,
like. I want it to AI to do things that I do not like or I do not want. I do not
yeah,
know how to do it, like images. I don't
yeah,
know how to draw. I create
yeah,
images, so I use it for that. So yeah.
yeah. And do people actually use it? Do you think for business intelligence and reporting? I think click answers can help. Or natural language can be used to the that's the NL insights in
Mhm.
Click, right? In Click Sense, you can use that. You get text summarization of percentages of things that can be calculated, the facts. So I think that's rather powerful, and also things that are not often used because people simply don't know how to use it. So in NL Insights in Click Sense, I love it. Um, but go tell a story around the narrative of a business intelligence dashboard. Yeah, we could use it as well. Um, but use generative AI to create and think of KPIs, or right, with the description, and that could be a good idea. But actually, visualizations, it's okay-ish to get an idea, but it's not very powerful in creating graphs and so
Yeah.
on. I
You know,
also think that it's
when I
still
use
not
it,
very powerful in
is there,
calculations.
but it's not very powerful calculation because it's usually a language model, not a math model.
Exactly. Yeah.
But you know what? I
Exactly.
used a couple
Yeah.
of times or maybe more, and it didn't give me the full answer. But it helped me just to get started the discussion. I
Yeah.
like did a data
Yeah.
module in Click, for example, for a couple of apps that some data sets that I was very familiar. And then I took a screenshot of the data module, put in one of these like Perplexity, for example, and I said, "This is a data model for an analytics application I'm doing. Give me an ideas of visualization I can do, some analysis, what kind of measures and
Yeah.
dimensions will make sense,
Yeah.
and I give a little bit of context. This is kind of the customer that I'm talking about." And he actually gave me an idea, and I put some idea like I want to use storytelling and data visualization, and it gives me an idea. Oh, you should do a bar chart doing this, and that's the business benefit for it. And then I talk about it. Well, yeah, I don't think I like that because of this, that, and that, and then it replies back and have a conversation. And then I have, okay, great, I have an idea, and I do something because a lot of times when it's the first interaction, the user has no idea what they want to see. So you show the first interaction, then they see it, the art of the possible, then you get the conversation started. And I use Gen AI to get the conversation started.
Yeah, yeah, I like that a lot. What I do in my line of work as an advisor and trainer, I use it for Socratic interviewing, Socratic interviewing questions. So when I have a strategy, I anonymize it. I put it into ChatGPT. Give a little bit context. Give context, of course, and who I'm doing this for, and then I'm asking for Socratic interviewing questions to get the mission and the things around it to pay attention to get it more clear so I can interview the stakeholders in an easy way. The other section, what I do is when I use my requirement analysis, I can build a user story, but then I put the user story in ChatGPT and ask for Socratic interviewing questions to make the user story even more clear, to know what to ask. So Socratic interviewing questions is, I think, a very powerful way of using ChatGPT. I also generate synthetic data, so fake data, with the help of generative AI solutions to get my ideas
Mhm.
going in building something simple because I'm not truly a programmer.
Yeah, you want to do a
Um,
demo, yeah, then it's
but
hard to
then,
find a data source, and yeah, that's a good idea.
yeah, sometimes it's a good idea when I want to think of something. I just produce 100 lines, start with 10 lines, and then I build it up, and then I say, okay, now you can create me 100 lines, and then I have a basic data set that I
You know,
can
I did,
use.
I
But
did,
yeah, then we
I don't use, I use Gen AI for that for some time, but now I have some Python codes that I have, that basically I have some parameters, and I get this is the type of data I want, and then give me this number of rows, and it does like based on statistical properties. So kind of numbers kind of make sense, create fake names that look like new real
yeah,
names. But anyway, I'm
yeah,
that's a
that's
different
cool.
topic.
But then, yeah, and I think the next topic, is data literacy and including ethical thinking and handling of data. So we will include that in that topic. So, um, what does it all mean for data literacy? What is your opinion about this? Because I know the topic is written to me, is given to me to discuss it, but I really would love to hear your vision, your opinion about it. What does this everything had to do with data literacy?
There's some people call this AI literacy, which I disagree. I think AI without understanding of data and the properties of data, it's really dangerous. Like understanding AI technology and how to use it without understanding the properties of data is really dangerous. So I think it should be part of the data literacy thing, and I think it is important. It's a we cannot deny it. People we use are using. This has a power to change and transform society. It already changed and transformed a lot of businesses, and a lot of professions. So I believe it is important. Do I believe that we are in a point that an entire person will be replaced by an AI? I don't think so. But I think you will become more productive if you know how to use it. But knowing how to use is not
Yeah,
how to generate content the way you like it. Is also to understand how does it work, not in a deep level like developer level, but in a deep
from a
well,
basic point
yeah,
of view,
but
basic
in a in
level.
a
Yeah,
in a deep well level that you understand, for example, biases that exist, the biases that do exist. You understand
yeah,
about hallucination, that do you understand about um, ethics,
ethics.
responsible AI,
Yeah,
and you understand the impact
yeah,
of that. You understand like how you do fact checking and
yeah.
all of those like laws of data privacy
Yeah,
and all of these.
I think it's a good way to discuss data literacy, right? Data literacy, and for marketing terms, I call it data and AI literacy. I look at it from a broader point of view, right? I look at data literacy and AI elements. You need to know the basics and you can advance yourself. So it's a subset of data literacy, AI literacy, prompt literacy, visual literacy, coding literacy, and so on. So you have all those subjects that regard that one phenomenon in the middle, which is called data. Data is the basis of everything. Without data literacy, we can't do anything because we won't have good data, we won't have good results, right? So I think that's a very important element to think of. It is data literacy, um, but I truly believe that that there will be a shift in roles. It's not. I think some jobs will go, new jobs will create it. We need to embrace the digital era, right? This era, we have to embrace it, regarding the analytical skills, the questioning skills, the creative skills, and so on. I don't believe we will be replaced by AI robots. No, I don't think so. We need to safeguard the fact that humans need to be in the loop and stay in the loop. Um, but then, and we have to be ethical in the things that we do. Take care of the fact that bias needs to be recognized, but also needs to be handled in a responsible way. So yeah, I think it is indeed, as we stated and discussed earlier, it's job evolution. It's not job elimination. Elimination, a very difficult word for a Dutchie
Oh,
at this
you got it
hour
right the
because
first
it's.
time.
So actually, the key takeaway here is that generative AI is not something like a silver bullet or the golden egg. It's more like the next generation of power tools. If you're skilled enough, it can give you uh, fuel to grow and be more predictive, because routine tasks can be done easily. I know Melissa is a girl from Tampa, Florida, and she is also a trainer in Gen AI, and she produced emails automatically with Copilot, which was amazing because she only had to copy and paste it into her email and send it out, ready, customized per employee. Amazing stuff that I saw. So it can give you some convenience in time, right? Um, but if we are not trained enough, and if we are not trained, then we could have some risks going on within an organization, within our lives, because fake news is everywhere. Fake images, fake videos, it's all around us, and we need to question the things that we see. So I think we go to the next section, and that is the data story that you wanted to
Yeah, and
discuss
I'll
with
make it
us.
very short.
Let's.
So we back to data story. I think is a fun segment we have in our episodes. Today's data story is about a paper published in the Alexandria Engineering Journal, and it tackles a classic machine learning headache, which is class imbalance. So think about, for example, fraud detection. Your data set has thousands of legit transactions that are not fraudulent, and barely any fraud, but you have, let's say, 0.5% of frauds. So when you're creating a machine learning, let's say in Click Predict, to predict if a transaction is it's legit or is a fraudulent transaction, the model it skews. So the model basically it's not very good to predicting fraud. Is what we call, or it's what I call the rare condition challenge. So basically, imagine you have a very rare disease that only happens in 1% of the population. So if you have no model, your algorithm is basically saying everybody is safe, everybody's healthy, nobody has the condition. It's a very stupid module because there's no module, just saying nobody has it. It doesn't exist. Still, you get it right 99% of the time. Pretty good accuracy, 99%, because it's so rare that you get it right most of the time. But it's really terrible of predicting those rare 1%. So that's unbalanced, very problematic. Now, what we do usually, you can tweak, like we call the loss function, to basically give a higher weight for those rare conditions. So if this happens, then you have a higher weight, so then we count for those rare conditions. Or you can generate synthetic data just for the rare conditions and have every column respect the statistical properties of the data set. There's some other methodology about that, but this paper brings an alternative. They use the GAN. Remember that we talked about the GAN, the Generative Adversarial Network, but they do an advanced one. They did the RGAN. So it's a one type of the GAN, and I'll explain very briefly what this does. But basically, they get the GAN and they do a regularized. That's where the AR come from. Generative Adversarial Network. So basically, this model generates synthetic fraud cases or rare condition cases, and there is a discriminator. Like, remember those two adversaries, the one that evaluates. So the discriminator,
the generator and the discriminator.
The generator generates those synthetic, and the discriminator tries to identify if they're real or if they're not. Why is that interesting? Because this smart regularization and this technique gets models that are much better than the data without this intervention. So maybe you do that in your model that has this class imbalance. There's a lot of things in here. The name of the paper is Advanced RGen, Generating Anomaly Data for Improved Detection in Imbalanced Data Sets Using Regularized Generative Adversarial Network. Is a long title, but anyway, in the description of this podcast, I'll put the link for the paper if you want to read the paper, which you can find also on our website. And if you want an article in our blog about how to prepare data for unbalanced data sets for Click Predict, leave a comment, let us know. We might consider, we might write it. And I think it's time to say goodbye. So before goodbye, follow us, like us, share our content, and see everything we do at datavoiders.net. Thanks, Angelika, as always, to be a great partner in this endeavor. And bye-bye. Ciao, pessoal.
Tot ziens. Goedenavond. I'm going to bed in 1 hour, I think. Just have a drink. And thank you to our amazing sponsor, IPC Global, again, for being with us and helping us with the audio and putting it on Apple and the other channels. So thanks. Follow us, please. Give stars.
Bye.
Data